But in the process of learning how to take one complex number and divide it by another complex number, what we really need to understand is the idea behind a complex conjugate. Now, in the last few lessons, I've introduced what a complex conjugate is. Now we're finally going to actually use it for something. So let's go take a trip down memory lane for a second and talk a little bit about conjugates, because we need to really understand that in order to divide these numbers. So the conjugate, we call it the conjugate of, forget about complex numbers, the conjugate of the number or of the expression 1 plus the square root of 7. We've used this kind of thing before. We say the conjugate of this is 1 minus the square root of 7. And we used this before because when we had radical expressions with a term like this in the denominator of a fraction, we basically don't want any radicals in the denominator of any fractions. So what we figured out is that if we take this term and we multiply it by this term with all the cross multiplication, you can see what's going to happen. The interior term is going to be square root of 7. The outside terms will be negative square root of 7. And then, so they're going to add to 0. And then when you multiply the last terms, you see the square root of 7 squared is going to kill the radical. So by multiplying by the conjugate, we eliminate the radical. So we use the conjugate to get rid of any radicals in the denominator of fractions. We've done that in the past. So now we need to move on to working on today. So we say what we call the complex conjugate of, and we'll just take a few little examples. The complex conjugate of the complex number 1 plus 3i is just simply 1 minus 3i. All you do is you take a copy of the exact same number, but just switch the sign. Plus becomes minus. Let's take a look at the next complex number. Negative 1 minus 2i. We say its complex conjugate is negative 1 plus 2i because it's exactly the same thing. Negative 1 and then the 2i, we just switch the sign of the interior guy. One more example. Doesn't matter if you have fractions here or not. If you have 1/2 minus 1/2 times i, the complex conjugate of that is 1/2 plus 1/2 I. You make a copy of it, you switch the sign. So positive becomes negative, negative becomes positive. So we say that this is the complex conjugate of this, and we say that this is the complex conjugate of this. So these complex conjugates happen in pairs. And notice that this is still a complex number because we still have i's, and this is a complex number, we have i's involved. But what ends up happening is when we multiply a complex number times its conjugate, what ends up happening is that all of the imaginary numbers disappear because of cancellations and such. So we're going to use the complex conjugate to get rid of any imaginary numbers in the bottom of fractions. So we said before, we don't want any radicals in the bottom of a fraction. We've learned about that in the past. Well, since the imaginary number I is actually a radical, it's the square root of negative 1, right? Then because we don't want any radicals in the bottom of fractions, we also don't want any imaginary numbers in the bottom of fractions. So what we want to do when we simplify these things, all of these problems, essentially is going to boil down to getting rid of any imaginary numbers in the bottom. So for instance, 5 over 3 plus 4i. This is a division going on with a complex number. This is a complex number. Of course, it's just got a real part of 5 and an imaginary part on the top here of 0. But it's still complex, right? And you're dividing it by a complex number with a real and an imaginary part. How do you actually do that division? Do we write a division symbol, you know, like in basic math and start trying to divide it? No, what we really do is we say, well, we first try to simplify anything in the top and the bottom that we can. There's nothing we can do. Once you get down to that point, all you try to do at the end is try to eliminate any imaginary numbers in the bottom here. So what we have to do is, in order to do this, just like we cleared any radicals from the denominator, we need to multiply by the conjugate, but since this is a complex number, we multiply by the complex conjugate. So we multiply by 3 minus 4i. And then, of course, we have to do it on the top because we want to be multiplying by 1. So this is just a number 1 multiplied by what we started with, so we're not changing anything. And so what we end up having here is we have to multiply the 5 times this. Now here's the thing I want you to think about. I'm not going to do it for every problem. But anytime you have these complex numbers on the numerator and the bottom, I want you to imagine invisible parentheses are surrounding them, like this. And also over here. You could draw it around the 5 if you want, but it's kind of not terribly helpful. We could do that if we want, no big deal. You can go ahead and envision them there because then it helps you think. when the 5 is multiplied by this, it gets distributed into each term. So the 5 times the 3 minus 4i. 5 times 3 becomes 15. 5 times negative 4i becomes negative 20i, because 5 times 4 is 20. That's the numerator. The denominator, we have to multiply these complex numbers together, and now we know how to do that. So 3 times 3 is 9. Inside terms, 3 times 4 is 12, but we have an I, so it's 12i. 3 times negative 4 is negative 12i. Notice we have a nice cancellation going on here. Negative times positive gives me negative. 4 times 4 is 16. I times I, don't forget that, is I squared. So for the next step, what's going to happen here is we're going to have 15 minus 20 times I. And in the bottom, we're going to have the 9. All of this is going to subtract away, but we have this minus sign, 16, and then the I squared we need to substitute for negative 1. So you see it already looks a lot simpler. Moving along, in the numerator, we'll have 15 minus 20 times I, and in the denominator, we'll have 9. This becomes a positive 16. And so then we will have 15 minus 20i. And in the denominator, what is this? 9 plus 16 is going to give me 25. So you could basically stop there if you wanted to, 15 minus 20i over 25. However, you notice this is divisible by 5, this is divisible by 5, and this is divisible by 5. So if you do a math problem and you give me an answer of 5/15ths as the answer, 5/15ths, or 2/8ths, or 5/10ths, I mean, yeah, it's right, but you could have simplified all of those fractions, right? So this is just a little more complicated because we know these are all divisible by 5, but it's a complex number on the top. So often in the beginning, you don't know what to do. So here's what you want to do. You want to cancel the common factor of 5 from the top and the bottom. Here is the cleanest way to do it. What I want you to do on the top is just factor out of 5. So we can write the top. We know this is divisible by 5 and this is divisible by 5. So we can factor out of 5. 5 times 3 is 15. We have a minus sign from here. 5 times 4 is 20, but we have the I here. So this, you should convince yourself, when you multiply back, gives you the top. On the bottom, you have the 25. All right, now that we have a 5 kind of pulled out, and then we have a 25 on the bottom, you can say 5 divided by 5 is 1, 25 divided by 5 is 5. And so then for the final answer, well, it's not exactly the final answer, but closer to the final answer, it's going to be 3 minus the 4i on the top, but on the bottom, all I have left is 5. And again, I could simplify that, I could circle that as my final answer, but when we divide complex numbers, we want the number as a complex number, right? So when we divide 20 divided by 4, we want to get a number back, a complete self-contained number. What we have here is a complex number divided by 5. So what you need to do is work backwards. And I'm going to do it once. It's going to seem weird, but then as we solve more problems, it'll become common sense, or it'll become more familiar to you. This has 2 terms on the top, and we have 1 term on the bottom. We can break this up as follows. 3 over 5, minus sign from here, 4i over 5. Or a better way to say it, let's just do it like this. Yeah, 4i over 5. First, make sure you understand this step. If I give you this and say, how do you add these? These are fractions. I mean, yeah, there's an imaginary number, but it's not really any different. You have a common denominator of 5. So the answer that you get is going to have a common denominator of 5. And then you have 3 minus 4i in the numerator. 3 minus 4i in the numerator. So it's very easy for you to look at this and know how to get here, but we don't often in math look at this and have to break it up. But we want to do it with complex numbers because we always write them as a real part and an imaginary part. So in almost all of these problems, you're going to get down to the answer, and then you're going to have to break it apart into the real and imaginary. So all you do is you say, well, this is 3/5 minus this over 5. And then this is actually totally acceptable, but a better way to write it, I think, is 3/5 minus sign 4/5 times I. This is the only change. 4i over 5 is exactly the same as 4/5 times I. I like to see it like this because the real part is 3/5, the imaginary part is negative 4/5 I. That's the imaginary part. And this is a true complex number. You can have the real part, you can look at it on a number line, the imaginary part, you can plot this in the complex plane like we've done before, and it's very easy to understand. So all of the problems will behave the same way. When we divide these things, we're going to multiply by a conjugate. We're going to do a lot of math to multiply by the conjugate. We're going to get a number on the bottom. And then we'll have to simplify. Usually we'll have to factor, cancel, simplify, and then break it all up again at the end to make it pretty. All right, next problem. This is no harder than the last one, but we're just getting practice. What if we have 2 divided by 3 minus I? Well, again, there's not much to do in the numerator or the denominator, so now we just want to get rid of the imaginary number in the bottom. So we say 2 over 3 minus I, and we have to multiply by something to get rid of that imaginary number. And the only way to really do it is to multiply by the conjugate, 3 plus I, and on the top, 3 plus I. And again, you can imagine invisible parentheses surrounding all of these terms to help you visualize the multiplication process. But at the end of the day, what you're going to have here is on the numerator side, you're going to have 2 times this complex number, so you distribute. 2 times 3 is 6. 2 times I is 2I. This is the numerator of the answer. The denominator is much more involved because we have to do FOIL. 3 times 3 is 9. Inside terms is negative 3I. Outside terms is positive 3I. Negative times positive is negative. I times I is I squared. That's the final kind of intermediate answer of the end here. But what we have is 6 plus 2I on the top, and on the bottom we have a 9. We have a negative 3I and a positive 3I. They go away, but we still have a minus, and we have an I squared, which we can substitute for minus 1. So what you really get is 6 plus 2I over, this is 9 plus 1. And so just to make it totally clear, 6 plus 2I over 10. Now, again, you could probably circle that, but it's not exactly in the right form. Number one, it's not written as a complex number should be written. It's not written as real part plus imaginary part. So we want to fix that. Secondly, we see that this is divisible by 2, this is divisible by 2, and this is divisible by 2, so we think we can simplify it. So what we want to do first is we want to factor out a 2 on the top. So this would be 2 times 3 would give me 6, and then 2 times 1 would give me 2. Don't forget the I here. Make sure that going back in gives you what you started with, and you have a 10. Now by factoring it out, you can more easily see that we're going to have 2 divided by 2 is 1, 10 divided by 2 is 5. So then what you're going to have is, when you do it, 3 plus I over 5. That's the simplified kind of fractional form of that complex number. And then what you have to do to write it properly is you have to break this up into real and imaginary parts. So you say 3/5 is the real part, plus whatever's over here, I over 5, like this. And you should always check yourself. If I were given this, I would say, okay, I have a common denominator of 5, and I would just add the numerators, which would be that. So you can circle that. I would give you full credit, but a better way to write it is 3/5 plus this should be better written as 1/5 times I, because then you can read it off. The real part is 3/5, the imaginary part is 1/5. 3/5 plus 1/5 I. All right? Not too hard. Dividing complex numbers essentially becomes multiplication, essentially. But when you really think about it, dividing any number really becomes multiplication. I mean, if I take, 2 divided by, let's do 8 divided by 2. 8 divided by 2, right? That's division. That's what we do was division. But 8 divided by 2 can always be thought of as 8 times 1/2, right? So you can always turn the division, dividing by 2, you can turn it into multiplication of something else. So we're dividing these complex numbers basically by doing multiplication. And that's pretty much how you're going to divide complex numbers, at least for now. We're going to revisit this a little bit down the road and show you a different technique down the road. It's a different ball of wax. But for now, this is how we're going to do it. So last problem, if we have -1 minus 2 times I. On the bottom, we have -1 plus 2I. So interestingly, this is the conjugate of this. We have a conjugate in the numerator and the conjugate in the denominator. So it'll be interesting to see what happens here. What do? Well, we can't simplify top or bottom, so we're going to rewrite the whole thing, minus 2I. And then we'll have -1 plus 2I. And then we have to multiply by the conjugate. And the conjugate here of the bottom term is -1 minus 2I. And we have to do it as a fraction, -1 minus 2I, like this. All right? So we have a multiplication going on in the top and on the bottom that we have to take care of, and it's helpful for you, again, to think about invisible parentheses kind of around all of these. So in the numerator, we have FOIL that we have to do. It's more complicated than the previous problem. So we have -1 times -1 is going to give me positive 1. The inside terms, -1 times -2i is going to give me positive 2i. The outside term, -1 times -2i, again gives me positive 2i. The last term's negative times negative is positive, then 2 times 2 is 4, and I times I is I squared. So that's the numerator. The denominator will be very similar. -1 times -1 is positive 1. Inside terms, -1 times the 2i gives me -2i. Outside terms, -1 times -2i gives me positive 2i. There's our cancellation showing up here. Negative here times positive 2i is going to give me the same term, except it'll be a negative here. -2 times 2 is 4, I times I is I squared. And so then we can simplify over here. We have a 1. 2i plus 2i is 4i. Then we have 4 times the I squared, which is -1. We'll handle that in the next step. Here we have a 1, but notice we have a cancellation. This guy becomes 0, so it drops away. We have a negative sign, and then we have a 4, and then the I squared, again, is -1. So notice we don't have any imaginary numbers in the bottom, which is what we wanted to do in the first place. So what do we have here on the top? We have 1 plus 4 times I. This becomes a -4. And on the bottom, we have a 1. This becomes, when you multiply by the -1, a positive 4. So what we have is, what's 1 minus 4? You get -3 plus 4i over 5. Let me catch up to myself and make sure I'm okay so far. -3 plus 4i over 5. That's right. So again, you want to break it up into the real and imaginary parts. So you say, because there's nothing to factor out. I can't factor and cancel 3, 4, and 5. There's nothing else to do there. So you have -3 over the 5. And then plus, you can do 4i over 5. Make sure you understand that. Common denominator, if I were to add them, and then this plus this is exactly what I have. And then let me clean it up a little bit. Let me write this as a negative sign, 3/5. The fraction will be 3/5 plus 4/5 times the imaginary number I. So we have -3/5 plus 4/5 I. This is what I would want to see as the final answer. So I hope you've seen in this lesson that dividing complex numbers basically always becomes a multiplication, at least dividing them now at this point in your education. It turns out later down the road we're going to represent complex numbers in a slightly different way, a different way of thinking about them that makes multiplication and division even a little bit easier to do than this. But for now, it all boils down to turning division into multiplication. So you try to clear out the denominator, it becomes multiplication, and then you just simplify the answer. So we have one more lesson. We're going to be continuing to divide complex numbers. These problems in the next lesson are significantly more difficult, but the same process will apply. No new rules, just we have to be a little bit more careful with our actual work. So follow me on to the next section, and we'll wrap it up with dividing complex numbers. Learn anything at mathandscience.com.